Did you imagine at the time that it would have the ramifications and implications that we're seeing today?
You know, the simple answer, of course, would be no, but it's not true. That's not a fair answer. If you think about this a little bit, first of all, remember that the ARPANET project, the predecessor, had already encountered electronic mail. A guy named Ray Tomlinson at BB&N, Bolt, Beranek, and Newman, realized that he could do networked electronic mail if he just forwarded the messages through the network and got them to go to the right target machine. Mm-hmm. And then he had to figure out, okay, I get to the right machine, how do I tell it which user it is that I am supposed to be sending this message for? And he needed to separate the machine identity from the user identity, and the only character he could find on the keyboard that wasn't already in use by the operating systems was the @ sign. And so it's kind of natural, user @ host. So that's the origin of the @ sign in our email. So he does this and demonstrates it in sort of mid-1971. Everybody gets excited about this. We all realize what a powerful tool this is. It's computer-mediated communication. We no longer have to both be awake at the same time to communicate, so we can overcome time zones and everything else. And so email was already in place before internet work was even started. So that's a long way of saying that we actually had some appreciation for what this technology could do. Mm-hmm. And we used it to do a lot of the applications that we still use today: electronic mail, file transfer, remote access to time-shared machines. But of course, the most significant change after the internet finally gets operational in early '83 and then becomes commercially available in 1989 is Tim Berners-Lee's development of the World Wide Web. Mm-hmm. And to be honest, Tim releases this out of CERN in Geneva in sort of December of 1991. Nobody notices, except for a couple of guys at the National Center for Supercomputer Applications, Mark Andreessen and Eric Bina, who say, oh, this is cool. Why don't we build a graphical user interface? So they develop the Mosaic Browser. Mm-hmm. They release this. It makes the internet look like a magazine with formatted text and images and eventually, audio, video, things like that. Everybody notices. And so this introduction of this new way of sharing information on the net had a profound impact on its accessibility and utility. What we had achieved is this infrastructure that was infinitely, well, not really, but largely expandable. It dropped the barriers to access to computer communication to as close to zero as possible. Hmm. We had given away the design of the internet for free with no patents or any other constraints deliberately in order to stimulate adoption and use. So as the general public encounters the World Wide Web, they have the ability to inject content into the network with very little barrier, and of course to get access to that information. In fact, there was such an avalanche of content that flowed in that we now couldn't find anything, and we needed search engines. So we got things like Alta Vista and Yahoo and eventually Google, Bing, and so on. So this question of did we know what was going to happen? No, but there were milestones in the course of the evolution that signaled that this was going to be a big deal. And it was the commercialization in 1989 of the service, as opposed to commercialization of the equipment like packet switches from Cisco Systems or Proteon or others. Yeah. It was the commercialization of the service and the arrival of the World Wide Web that really conflated these two things. Then there's one other thing which I think was equally significant, and that's the arrival of the smartphone in 2007. This is Steve Jobs and Apple. Mm-hmm. And at that point, you see a phenomenon which is very important to understand. Two technologies that are mutually reinforcing. Mm-hmm. The mobile phone makes the internet more accessible. The internet makes the mobile phone more useful because of all the content and functionality that's on the net. And so those two things together have really colored the last decade of the evolution of the internet and on the products and services that go with it.
And then the more apps that started appearing for
exactly right. Yes, because we have a platform So the interesting thing about all of this is the layering that's going on. And the internet is a layered architecture. TCP, IP is the sort of the core layer. TCP and the other real-time protocols are just above that, and then there are utility protocols like file transfer. When we get to the World Wide Web, it's another layer. The hypertext transport protocol sits on top of TCP. And then, on top of the mobile phones, we get APIs that make it easy for people to build applications, even if they have no idea how the mobile telephony part works.
Yeah.
And it's this isolation of knowledge, of necessary knowledge, and the stability of the interfaces, whether it's a stable protocol interface or a stable API, that the longevity and stability of those interfaces allow people to do things without having to know very much at all, if anything, about how this works underneath.
Yeah.
So you create this opportunity for invention without a whole lot of overhead.